Welcome back to another live stream repair. We're going to be knocking out this HomePod here today. Looks like we've got a bit of a break this weekend for once. Nothing else showed up. We had this one get dropped off yesterday after our streams, so let's get it fixed up. Something a lot of people may not know is how removable the power cables on the first gens actually are. You just give it a good firm yank. Alright, let's power this up and give a listen. Oh boy, that's quite poppy. Alright, give me 1 second here. I'm going to send a link to Matt so they can watch the repair. Share, copy that link. And sent. Okay, so as I was saying, we've got Matt's first gen HomePod here with no power. It was dropped off yesterday after our streams, so we're gonna go ahead and knock this out. So we've got 1 weekend off. I'm gonna go ahead and show you guys really quick what's going on here. We'll go ahead and power this up. And what happens, and what we'll be fixing here today, are the filtering capacitors on the amplifier inside. Well, actually, all ceramic capacitors naturally decay over time and lose their effectiveness at filtering DC voltage. So, these in particular, they're filtering out unwanted DC voltage from the amplifier as the audio goes through and into the subwoofer speaker. And, well, can't have that kind of decay when we're talking about millivolts of DC that get amplified and turned into enough power to fry subwoofer speakers and whatnot. One of the hallmark signs of this, of course, is that popping sound as they wake up or go into standby or low power mode. A quiet tick or pop by itself is not a problem. It's only really a problem or a sign of a problem when it's really noticeable or more characteristic of like a loud thud. Especially if you have death farts where it plays that loud buzzing sound and then force restarts on you. That is actually when it is a problem. But all first gens and heck even the big second gens make a quiet tick or clicking sound as they wake up or go to sleep, and that is perfectly normal. But listen to this.
I'm having...
And then listen again. That's not healthy. So, we're going to get this cracked apart, and we will replace those ceramic capacitors that are no longer filtering our unwanted DC voltage. And we'll take a peek at everything else while we're inside, see if there are any other problems. In a lot of cases, when those filters go bad, they don't just make your HomePod fart and restart on you. Eventually, it will cook your subwoofer speaker and make it less effective or completely broken. Sometimes we see various components on the amplifier board itself blown off. You know, basically things that weren't built or expecting to see that much DC voltage suddenly seeing DC voltage. Just Class D audio amplifier things. Get a little closer. One other thing that we'll be looking for once we get inside is the date code on the Schottky barrier diode, also on the amplifier board. There are two date codes in particular of those diodes that commonly fail and cause no power, which is by far and large the most common issue that people send their HomePods into for us to get fixed up here on the channel. So we can tell by the date code on that diode if this HomePod will have that same problem or not, and we can prevent it if so. But I will point out that date code to you guys when we get inside and up close. For now, we've got those screws exposed. Let's get them undone. And then we can get our flathead, and what we did a minute ago was we took some 99% isopropyl alcohol and we dripped it inside there to weaken the glue that's holding this basket down. So that, you know, only a couple little twists and this thing will pop right up. Much easier than doing it without it. It's totally doable without it, but one of our watchers a few years ago had left a tip. They were like, hey, if you drip some rubbing alcohol in there, it makes prying the basket up a lot easier. Alright, and I just completely glossed over it, but if we check the condition of our subwoofer speaker, we want to make sure this hasn't been destroyed from that DC voltage. You can see the condition of the voice coil by looking through the inspection window there. We're looking for a nice copper color, nice even copper color, and we're looking for smooth, quiet operation as we move it in and out. And last and most importantly, smelling for any stinkiness, and it passes everything with flying colors. So the subwoofer survived. And that is mostly because I asked Matt when they dropped it off, did you guys leave it and keep using it for a while after you noticed the problem, or did you unplug it and leave it as soon as you noticed? And that's what you want to do. If you notice it start to death fart on you, you want to unplug it and get it fixed. You don't want to ignore it. Even though it works for another 10 or 15 minutes before it farts and restarts on you again, it's screaming for help. It's literally screaming for help. And it's killing itself. So, mostly because they stopped using it as soon as it started having that problem. They prevented any more damage happening here. And it looks like the only thing we'll need to worry about in here are those filters. There we go. We are at our amplifier board now. Let's get up close. And the first thing I'm curious about is the date code on our Schottky diode. Like I was saying earlier, this is the part that tends to fail and cause no power in these HomePods. It's the most common issue, I'd say. Probably more common than those death farts, believe it or not. In this case, they've got a date code of 1742K, which is older than the diodes that we see failing and causing no power. So basically, we don't need to worry about touching that. It's never going to fail on them. Next up, we've got our 10 ohm resistor here. This tends to fail when there's death farts and too much DC voltage, and that's looking fantastic. I'm going to look at our amplifier chip here on the back, make sure it's nice and healthy, doesn't have any holes or hot spots on it, and it looks great as well. So basically, everything else on the board looks great. No major concerns sticking out. We're going to go ahead and get those filters taken care of. And here they are. You get 4 of them. Even though you have 4 of them, it only takes 1 of them to go bad for things to go kaput. And put it into perspective, the amplifier chip right over here, this is what amplifies the audio signal and feeds it to the subwoofer. We have data sheets for it, and we know that it can tolerate up to about 18 millivolts at its input, which at the output is about 180 to 200 millivolts. And a AA battery is 1.5 volts, or 1,500 millivolts. So it really doesn't take a whole lot of DC voltage to do a whole lot of damage and cause problems. I was wondering why this was not melting, and for some reason my heat gun was turned down. There we go. I was gonna say that should not take that long. So we got the old caps off. Let's put some flux on there. Get some fresh solder on those pads. A little more flux. And some new filters. Beautiful. Okay. It's time to put this pod back together and test it out. We should be able to tell right away if we've got the problem fixed or not by how loud, or rather how quiet, it will pop when we turn it back on here after we get it back together. When we tested it before we got started here, it was popping rather loudly. You can go back to the beginning of the repair stream and listen to that. Ooh. There we go. A little bit of heat to soften up that adhesive and make it nice and sticky again. And we've got ourselves a fixed HomePod. Oh yes, that sounds excellent. Give it a chance to time out connecting to Wi-Fi and give us an audible response here, just to make sure. Volume buttons light up nice and even.
I'm having trouble connecting to the internet.
Yeah? I mean, sorry for the kid, but I think you can hear the lack of popping. We'll leave this testing overnight just to be sure, but from what we can tell, this is all fixed up and good to go. Hope you all enjoyed this live stream repair, and I'll catch you in the next